Hi Starly, welcome to this lesson. In this lesson, I want us to look at parallel vectors and collinear vectors. Now previously, we looked at free vectors, okay? We saw how we can write free vectors in component form if they have been given just as directed line segment drawn on the grid or on the x or y plane. Let's look at parallel vectors and collinear vectors and see what type of vectors are these. Let's start with parallel vectors. Parallel vectors are vectors with the same gradients, and they are going to be in the same direction. Okay, so basically you have two vectors that are parallel. So I'm going to show those vectors by drawing two directed line segments that are parallel to each other, like that. Okay, and another one, I'm going to show it somewhere right here. Okay, so these two vectors are parallel. Let me show the direction. Okay, like that. Okay, so let's call this first vector, let's call it as vector A. So this is going to be our vector A. Okay, this is going to be our vector A, and let's call this second vector as vector B. They don't have to be necessarily be equal, but they just have to be parallel. Of course, they can be parallel at the same time, they can also be equal, but in this case we are talking about parallel vectors. So essentially I just want to have vectors, two vectors that are parallel to each other. Okay, so we are saying they should have the same gradients. So the gradient for this first vector, let's call it its gradient 1. Okay, let's call it M1. Okay, let's call it the gradient for vector A is M1. Okay, and the gradient for vector B, let's call it M2. Now, because these two vectors are parallel to each other, it means that their gradient must be equal. Okay, so two vectors are parallel if they have the same gradient. So we are saying M1 is equal to M2. And because of that, what you discover is that if you use the concept of what we have right here, the gradient, what you discover that the value for y1 divided by x1 will equal to the value of y2 divided by x2. Okay, so this is just affirming what you have right here to say two vectors are parallel if they have the same gradient. Okay, so that is point number one. Okay, then they are saying they must be in the same direction. Now, you know what gives the direction of a vector. It is the angle, okay, the theta. So what we are talking about here is that if these two vectors are parallel to each other, then what is giving them the direction is the angle, and that angle must be equal. So let's say that here the angle that is giving the direction is the angle theta, and right here the angle that is giving the direction, let's call it angle alpha. Okay, so these two angles must be equal for us to have two vectors that are parallel to each other, and that's in the same direction. So here we are simply saying that the angle theta must be equal to the angle alpha. Then we can be rest assured that we are looking at two vectors that are parallel to each other and they are in the same direction. Alright. Okay, so that's all about parallel vectors. They are basically vectors with the same gradients and in the same direction. How about collinear vectors? Now, before we can go to collinear vectors, let's talk about collinear points. We know that two or more points are collinear if they lie on the same straight line from coordinate geometry. This is how we defined collinear points. Okay, collinear points are points that are lying on the same straight line. Okay, so for argument's sake, let's say that we have got 3 points. Okay, let's say that this first point, let's call it point A. It is given as -3, -5, and then we have another point, point B, which is given as 0, -1, and let's have the last point what point can this be? Let's call it point C, and its coordinates is given as 3, 3. Okay, so let's see if these points are collinear, or they are lying on the same straight line. Okay, so in order for us to be rest assured that these points are collinear, they must be able to have the same gradient. So if we say that we join the point A and the point B with a straight line and then find the gradient for that straight line, we must be able to get the same gradient if at all we joined the point B together with the point C with the same straight line. So the line AB must have the same gradient as the line BC. Okay, so there are many ways that we can actually test that. So we can use the gradient formula, okay, to see if the gradient for line AB is going to be the same as the gradient for the line BC. Okay, let's try to sketch this and see what we can have here. Let's put this point on the grid. Okay, so let's say that we have, oh goodness, okay, so let's say that we have the y-axis. Okay, let's say that we have the y-axis like that. Then we also have the x-axis drawn just like that. Alright, okay, let's mark this. Okay, so we know that this is the origin. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the x-axis and that's the y-axis. Here we are going to have 1, 2, 3, 4. We know these are negative numbers. Okay, here we have 1, 2, 3, 4, 5, 6, negative, 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 negative. Then we have 1, 2, 3, 4, 5. Alright, so our first point was point A, right? Which was negative 3, negative 5. Let's try to plot this point here. Let me just write this nicely. Okay, we know it was negative 3, negative 5. Okay, let's try to plot the point. So the point negative 3, negative 5, it is right here. Okay, that's where the point is. So we say this is the point A. Okay, and the second point B, it was 0, negative 1. Am I right? Let's double check. Yes, 0, negative 1. This was 3, okay. So here we have 0, negative 1. The point is right there. Okay, that is the point B. So that is our B. And then we had 3, 3. 3, 3, 3, 3 is here. Okay, so this is the point C. Okay, let's see if we can connect these 3 points with the same straight line. Okay, let me use white here. So we have the point A, let's connect it to the point B, let's connect that to the point C. Okay, there. Okay, so after connecting the points A, B, and C, we can clearly see that these points are lying on the same straight line. Okay, therefore we can conclude that they are collinear points. But there is a better method of how we can show this to see if they are indeed collinear points. Remember what I said, we can use the gradient method to double check if these points are collinear. Okay, if these points are collinear, so here we have 3, 3. Okay, so what we can do is that we can get the 2 points here, AB, and find the gradient. Let's call that gradient as gradient 1, okay, where we are going to say that we are going to say negative, okay, let's start with let's start with the y coordinates. So if we say that negative 5 minus, so we say negative 5 minus negative 5 minus negative 5 minus negative 5 minus negative 1, okay, or let me change the way I want to present this. So let's say that we have want to find the first gradient for the point AB. So we know how that is going to be like, so let's call it M1. So we know that M1 is going to be Y2 minus Y1. So we're going to have that divided by X2 minus that. So here what we are basically going to have is negative 4, okay, divided by negative 3, and the answer is going to give us 4/3. So that is our M1. How about our M2? So our M2 is going to be, so here is for the line AB, alright? So the M2 is going to be for the line BC. So here we are going to say our Y2 is 3, then we take away negative 1, and then our X2 is 3, then we take away 0. So we are going to get 4/3. So you can see here we end up of having the same gradients. So you can clearly see that these points are lying on the same straight line. So it means that if we have, let's say this is now a vector that we can call vector AB. This one, let's say we have we call it vector AB, this guy here, okay, like that. And then from here to here, let's call it that now this guy is going to be our vector BC. So we say the BC vector. So it means that vector BC, vector AB, beg your pardon, vector AB and the vector BC are collinear vectors because they are all lying on the same straight line. Okay, so basically, so if you are saying these are vectors, of course they now want to show the direction of that vector, and because they are lying on the same straight line, of course what is going to give the direction to this vector is just the same angle there, theta. Okay, so this is how we can show that two vectors are collinear just by checking their gradient. If their gradient are the same, then we have vectors that are collinear, meaning they are lying on the same straight line. Okay, so from here we'll go into vector geometry and see how we can now solve some questions under vector geometry. So see you in the next video.